for everyone, thank you for attending again to this workshop. I'm Azusa Toriumi, as introduced by Professor Tan. So let me start the workshop. And before that, I would like to remind that you can have questions, ask questions, either right on the chat function in Zoom, or after each presentation, we are going to have a Q&A session, so you can unmute your microphone and ask the questions directly to presenters. Yeah, thank you. So first, let me invite Professor Takashi Oguchi from the University of Tokyo to introduce signal coordination control practices in Japan. So please start your presentation.
Okay. Let me try to share my screen.
Okay, it works.
Okay. Oh, sorry.
Another one?
No. Like this. Okay.
Okay.
All right. Thank you for your participants and kind introduction of me. I'm presenting the practice in Japan for signal coordination. My name is Takashi Oguchi from the University of Tokyo. And as Kishan kindly introduced me, I'm now leading so-called Advanced Mobility Research Center in my institution. This is the Institute of Industrial Science of the University of Tokyo. And 1 year and a half ago, we also start to organize a new organization, so-called Mobility Innovation Collaborative Research Organization. It's a cross-disciplinary organization across whole the University of Tokyo. We are now starting this kind of activities. And for today, as also Keisha mentioned, that I'm a bit busy with the project, national projects, and just try to summarize the Japanese practices in the signal coordination. And so firstly, I try to explain about the Japanese history on the introduction of the coordination control. And maybe in Japanese situations, the responsive control with the signal coordination is very common, so I'll also talk about that. And secondly, I'll try to explain the practices in Japan and the background theory. Actually, this is brought by my lecture slides. And the third one is also from my lecture, the signal coordination, and I try to enhance to the idea to the area-wide control. And fourth one is some application provided by the Japanese industries and also applied with the Japanese police agencies. Actually, in Japan, signal control is responsibility of the police agencies for each prefectures. And the national general rule is provided by the National Police Agency. Okay, firstly, for today's my talk, I try to read out, check the one history book. This is my first time to checking detail of this book, so-called Traffic Signal 50-year history. And I was very surprised that the first introduction of the signal coordination control in Japan is at Tokyo, and was on 1933. And the concept is very simple, that give this kind of signboard at the traffic signal with the 32 kilometers per hour. So try to announce to the drivers who try to keep the speed of this speed level. Then the driver can catch the next green. This and also try to give some timers with some DC circuit system. And this is applied for one line, one arterial with 15 intersections. And afterward, even before the World War, such kind of cabled systems is rather difficult for installation. So they just after 3 years, they changed to uncabled coordination with the synchronized clock. And in 1940, before starting the war, they already had more than 100 intersections of this kind of a coordination system. And after the World War II, maybe such kind of a technical application was stopped and suspended. But in 1953, a kind of a semi-actuated coordination control was started again in Tokyo, which means the cycle length cannot be fixed. It could be changed. And 1963, it is a kind of a national project. And they make a first trial of installation of traffic actuated signal coordination system. So set the detectors, and the 18 intersections have a traffic controller, and they are ruled by the main computer. And the idea is giving the set of parameters of the signal cycles and splits and offsets, and the combining there are 120 patterns, and try to select the patterns. And then with the three after have experience of the 3 years, in 1966 a first trial of the area-wide signal coordination. So at the Ginza area, this is the heart of Tokyo, actually the commercial heart of Tokyo, and the 35 intersections applied for this kind of trial. So not only the one arterial, but a kind of a network-wide applications, and introduced us a very fundamental idea to this system. And then rather full-scale the application started in 1970. This is the original form of the Japanese centralized traffic control system. And so this Ginza area is included here, and rather widened area application. This is the start of the Japanese history, I think, up to these days, today. This slide explaining about some technical manual, the background for such a practices. So the first manual on the signal control was published in 1969. And also a kind of a design manual of the intersection, a geometric design manual or plan also started. And it's parallelly published under different timelines. And in 1983, this is the first version, the so-called traffic signal control manual. Already rather detailed description related on the coordination is included. And in 1994, we have the revised versions, and a kind of established idea of the pattern selection of the coordinations included. 2006, revised versions, including some not parameter selections, but the real-time calculation methodology is also included. And very recently, we had the unified, comprehensive basic manual on the intersection plan design and the operations. Okay, so I also introduce the Japanese situation at this moment. So this number is also introduced in the first published book by WCTRS, as Kesha mentioned. And we had centralized traffic control centers. Basically, every prefecture in Japan, we have 47 prefectures, had a head of centers and some sub control centers, or also have some subset of the center in large cities. So a total number comes to be 168. And yes, as I mentioned, National Police Agency is have a responsibility on this. And any of those centers, main machines and systems are provided by these 5 Japanese industries. And the talk about the number of signals applied such a coordination. Okay, the more than 70,000 signals, intersections are connected to such a traffic control center and also have a coordination function. On the other hand, around 26,000 have a coordination functions, but they unconnected. Therefore, independently working and they set the coordinations. And the 900 push button is also connected to the coordinated. On the other hand, we had a rather large number of the isolated signals. Some of the major, our topic is try to connect those isolated signals with the 5G connection technology. All right, and so for the coordination, we had a very general, simplified idea of the coordinations and with the centralized control system. So to consider about the area-wide road network, we separate into the several sub-networks. And sometimes a group of the sub-network is having the same cycle lengths. Then try to connect the elements of the sub-network and they form the group of the sub-networks. So maybe you may see this is not so big subnet, but if you look at this area, this is a rather large subnetwork having the common cycle length 110. So maybe such kind of formation of the group of the subnets is one idea, having the common cycle length. And then determine the signal coordination for those intersections. So when you look at the intersections having one link connected with the different subnet, then we don't consider anything considered for the coordination between those two signals. That's the practices in Japan. So as you may also, maybe you are a specialist, that you may understood that the link length is one parameter to set the coordination offsets value, and signal time is also important, and the some vehicle speed should be determined. Okay, so our Japanese application is very simple for this considering about the coordination, that the consider the one arterials having the simultaneous start of the green time for both directions, even for having the different phasing systems, and focusing on the one arterial, and try to set the cycle lengths, and of course have some appropriate green split, and the coordination point of view, try to set the offset values, which could be explained by the percentage to the cycle lengths in general. Sorry. Okay. And for determination of the cycle lengths in Japan, maybe one typical feature of the Japanese signal control system is try to adjust cycle lengths every time, very frequently, and with the 1 second resolutions, as I showed, 101 second cycle lengths or something like that. And for the coordination point of view, the cycle length is determined at the critical intersection, which means the rather very busy intersections which should accommodate the traffic demand at the highest capacity level, so that avoiding the traffic congestions. So with such a high demand intersection, we should provide rather larger the cycle lengths. So the other intersections not critical in the same group of the subnet should apply the same cycle length as a common cycle. And yes, okay, this is for just brought from my lecture note. So basically, our Japanese practice is based on the concept of the flow ratio, demand flow ratio to the saturation flow rate is so-called a flow ratio. And applying the flow ratio value to select the green split value. This is a basic idea of the setting the green split. So for the even for the coordinated signals, also we apply the same idea basically. This slide is just explaining about the classification of the different aspects. First, the classification aspect is a spatial idea. So isolated or arterial and network. And for arterial coordination or network coordination, coordination is one important topic to determine the offset value. On the other hand, for control classification, is a pre-timed control or responsive control. Those two major differences we have. So as I mentioned, that the signal is intersection which connected to the traffic center, control center, then a kind of a responsive control applied. And they basically even as I mentioned, so 168 traffic control center we have. But the majority is still kind of a simplified the macroscopic traffic responsive control applied, and which means the predetermined some patterns of the parameters are just selected with the some detector information. And rather a few number of the application of the some program formation, which means the real-time calculation of the parameters. And so multi-program pretimes means the okay for the different day of weeks or some special conditions. We have a predetermined the cycle lengths, green split, and the offset values. And so such kind of predetermined coordination control applied at around 26,000, as I mentioned, and plus the less than 1,000 push button pedestrian crossing. For the responsive control, as I mentioned, that the control parameters, cycle lengths, green split, and offsets are selected or real-time calculated, and using the detector information. And for just that, consider about the responsive control, it is rather popular for the microscopic response, which means each intersections have a function of the responsive control. For example, right turn vehicles detection, and then extend the right turn phase or give a right of way for right turners or something like that. And on the other hand, from the coordination point of view, some macroscopic responsive control idea is also comes to be applied in Japan. So yes, selection or generation of cycle split offsets. And also for the oversaturation situations, we had also algorithms for select those parameters or generate the parameters. Actually, to tell the history of Japan, the reason why we started to introduce the traffic control center in the heart of Tokyo, Ginza, was to try to alleviate the traffic congestions. So the control system in Japan, basically, the development of the control system in Japan is basically pushed by such serious congestion issues. At this moment, more than 70,000 intersections are controlled with this macroscopic responsive control scheme. Okay, this is just a textbook telling story. For one-way street, okay, the coordination is very easy. But for two ways, okay, if give the right of way for the north traffic, but the south traffic cannot be met with the best coordination. So this is the issue, how to set the offset. And so the simple idea is considering about the return travel time should be the multiple of the cycle time. So set some cycle time, then such a best coordination distance is determined by this one with some given the travel speed, because of the travel speed is given by length divided by the speed. And so in our practice, always considering about this kind of the special case that the very well coordinated lengths or the worst coordination conditions with that changing the offset values, no delay reduction or no stopping conditions achieved. And to discuss showing, demonstrating the control delay, okay, for this kind of the best conditions, then we can achieve the no stop delay situation for both directions, northbound and southbound. On the other hand, for the some intermediate situation of the length of this one or this one, then these situations no effect for the total delay or average delay for both directions. And also, we had a knowledge about the cycle length optimization conditions, cycle length settings for the coordinated signals also. And basically, the cycle length, if the cycle length comes to be longer, then the minimum achievable delay, which means the well coordinated offset values, but still we should accept some level of the delays, then it will also monotonously increasing. And yes, okay, sorry. This achievement was done by Professor Koshi. Actually, the publication was 1989 in English, but he already proposed this concept in 1975 in Japanese. And so the Japanese manual applied his concept, so that in Japanese practice also following this kind of idea. This also showing the sensitivity of the coordination settings. And so at the best situations of this link length, or from here to this link length, then we can achieve the highest the coordination effect, which means when you set the most appropriate offset value, then you can achieve the minimized delay. On the other hand, at this link length situation or this link length this situation, so then maybe you can have any arbitrary offset values to achieve the same delay levels. And but this knowledge is very limited, because this is only introduced for 50% green split for two intersections which connected to the one link. So this is a very ideal situation consideration only. Only one isolated link with two intersections connected. Then we can apply this kind of idea. But the reality is maybe not 50%. Even those are same, or those two green split should not be the same. So what will happen? And several years ago, this is a joint studies, and we analyzed the characteristics of the signal coordinations, if but I will skip on this topic. And also generalize the achievement we got very recently. Okay, and this is also something interesting things that with some the range of the cycle lengths, we can achieve the minimum or zero delays, and this is the characteristics when we have the different green spirit value. Okay, then come back to the practice in Japan. Okay, I have only six minutes right now. So what is the offset pattern selection method applied for Japanese traffic control center? So this is the example of selecting tables. So with the detector informations, so one direction inbound flow ratio and the outbound flow ratio, applying those values, and with these values, okay, if the value is located here, okay, some pattern of the so-called equity 2 should be applied. But if the rather low outbound flow ratio, but on the other hand, inbound flow demand level is high, then semi-prioritize to the inbound, or rather priority to inbound, or something like that. This kind of idea is introduced, then put the offset values. and in addition, this kind of offset selections done for example, every 15 minutes, every 5 minutes, or something like that. And if the offset values are changed from the last 15 minutes to the next 15 minutes, then we should change the offset value. But the offset should not be immediately changed, because of the drastic change comes be the very short green spirit or very long time green time. So we had an idea also of the maximum change ratio. It is 12.5% of to the cycle length, and generally with the multiple cycles, and try to adjust the offset values. And also we should be careful that the changing direction, the offset value increase or decrease should be carefully selected, because the two adjacent intersections having the different direction of movement then comes to be the reverse offset conditions, which comes to be both sides facing with the red signal and come to be rather serious long queue lengths. Then, as I mentioned, that the kind of forming the subnet systems is based on the tree shape structure, not having the closed loop. Having a closed loop, then we cannot have the appropriate parameters for all the links. Sorry. And sometimes also we should reforming such kind of subnets. So the change shape of those subnets is also considered for every 15 minutes and so on. Maybe the time is very limited, so just explaining about several application cases published. First one is in 2013, the Tokyo Metropolitan Police Department experienced introduced. So from 2009 in Tokyo, the split is calculated very frequently, and the traffic demand is applied not only the just measurement, but a kind of a prediction is also already introduced, and the cycle length is calculated with the formula, and offset is also calculated using some simulations. So pattern selection is the rather the old fashions, and also the long the calculation duration required, but the rather short, and the rather theoretical form applied. Sorry, I don't remember what is this? Okay, this is the Tokyo Metropolitan Application Metropolitan Department practice started in 1995. As I mentioned, that pattern selections like using those tables. And okay, sorry. And the another things is sorry, when is this? The so-called moderato is a Japanese some parameter generation systems that they based on the very similar concept of the flow ratio, but the new idea is a load ratio, which could applicable for the oversaturated situation. It is something replaced the indicators with the flow ratio and try to set the green split with this one and set the cycle lengths. And the offset is not all calculated by the simulation based. Some pattern based pattern selection applied for oversaturated situation in the beginning, but at this moment they applied any conditions. Okay, in 1999. And these days, kind of some progression of the arrivals are also considered and already applied. Okay, then that's all my presentation for today. Thank you very much.
Thank you, Professor Oguchi, for your informative presentation. So we are going to have questions from the audience. So if you have any question, please raise your hand or write your question in the chat of Zoom, or unmute your microphone and ask question directly. No questions from the floor?
Sorry, if I may.
Okay, so Daniel, please.
Yeah, sorry, thank you. Just a quick question. You said the police do the coordination of the traffic signals. So it's police is in the government doing it. There are traffic engineers within the police. Is that right?
Good question. Yes, a very few number of the traffic engineers are assigned to the traffic control. And on the other hand, especially in Tokyo Metropolitan Police Department, they have a rather large number of the traffic engineers inside. And another important thing is the signal system industries, the companies are providing their knowledge on the systems, so that those company engineers are suggesting the appropriate system introductions and also parameter adjustment settings and the operations and so on. That's the Japanese practice.
Thank you.
I have a short question.
Yes, please.
Yes.
You showed us in one of your early slides, you showed us you replaced the ordinary loop detectors with probe, if I remember correctly. So is it practice or kind of still in the respect? Yes, next, yes, this one. The replacement with probe. You are saying that you are going to use the probe data to replace roadside detectors?
Yes, maybe for today, I didn't have a time to talk about that, but as you may observe that yes, such a very large number of the intersections are connected with the traffic control center, and traffic control center, one traffic control center, for example, in Tokyo, is connected to the very huge number of the intersections. Yes. And those control are based on the detection information by the traffic detectors. Therefore, also they should maintain the very large number of the traffic detectors. But these days, because of the limitation of the human resources and also the monetary budget, they try to reduce the number of the maintaining the detector systems. Therefore, they are very interested in the introduction of the using the probe information. So these a few years, they had a kind of a project, national project, and checking the usability of the probe information, but still not. It's ongoing projects. There are several projects, and so at this moment, not in the practice. That's the reality.
If I may, I would have also one question.
Yeah,
Thank you,
please.
Oguchi Sensei, very much. Thank you very much for the very informative presentation. Some of your slides I still have to digest, I guess. But you mentioned in the beginning the progression speed, and you mentioned that it's around 30 kilometers per hour or a little higher, which in Germany would be unusually slow. So could you say something about the progression speed?
All right. 32 kilometers per hour was the first introduction in 1933. Yes. And at this moment in Japan, basically we apply the idea of such a progression speed aligned with the speed limitations. So in urbanized area, 40 kilometers per hour or 50 kilometers per hour is the normal speed limit in urbanized area. So we are basically along with such a speed limits.
Okay,
that's the reality.
Okay, since we have limited time, thank you, Professor Oguchi, for your presentation and answers. So if you have further questions, we are going to have the discussion session at the end of all presentations. So you can write your question in the chat so that we can go through after all the presentation. Thank you. So
Thank
the
you very
next
much.
presenter is